Let's start with the demo. First of all, we'll log in to our Hedvig cluster. You'll see there are three data centers in this Hedvig cluster. The first one is in Azure Cloud with nodes as Azure Node 1, 2, and 3. The second data center is our West Coast data center with nodes as West 1, 2, and 3. And the third one being East Coast data center with East 1, 2, and 3 as storage nodes. We also have one storage proxy per data center, Azure proxy, West proxy, and East proxy. We can also click on each and every one of these storage nodes and look at all the capacity drives attached to this storage node. We can also see the total storage consumed for each and every drive for any given storage node. At the home page, on the left-hand side, we can also visualize total cluster size, total usable space, and other metrics. If you had volumes Hedvig virtual disk with dedupe turned on, you will also see deduplication savings on this home page. Let's create volume for our MySQL database. We'll click Add Disk, give it a name, give any size to this disk. We'll select the disk type as block and replication policy as data center aware with data centers as DC1 and DC2. This will mean the entire dataset for our volume will reside only in DC1 and DC2 data centers, and Azure Cloud instances will not even be touched. The second step for consuming this volume is to add LUN to our Hedvig storage proxy. And for this demo, as mentioned earlier, we'll select each one of the Hedvig storage proxies in DC1 and DC2 so that our clients which are residing on these data centers can consume this volume. So we'll go ahead and select East proxy and West proxy and click Add LUN. Third step is to provide access to our database clients. We have one client per data center. So we have DB client 1 for our West Coast data center and DB client 2 for our East Coast data center. Once this access is granted to our clients, they'll be ready to consume this Hedvig volume for the database instance. So far, we have seen Hedvig hybrid cloud cluster with 3 data centers and 1 storage proxy per data center. We have also created Hedvig volume and granted access to DB client 1 through West proxy and DB client 2 through East proxy. The second step will be to show you how DB client 1 and DB client 2 are set up in an active passive manner, and also start our MySQL database on DB client 1 using our Hedvig volume. I've already logged into each and every one of these clients. This is DB client 1. This is DB client 2. This is the DB remote client, which will be used for remotely accessing our database. And this is a script which contains SQL commands that I'll use during the demo. This is Azure client that is residing on Azure Cloud. Let's start with DB client 1 and make sure our MySQL database is not running at this point of time. We'll open MySQL configuration file to look at the data directory, which in this case is var lib MySQL. Now that this is done, we have to start our chorusing process on each one of these clients so that we can remotely access using virtual IP. I've already set up chorusing process such that it will perform 2 actions when the failover happens. First, it will mount this Hedvig volume on the second client, and second, it will restart the MySQL database instance on the second client as well. In order to simulate the failure scenario, I'll use this command pcs cluster standby, which will make sure that the chorusing process thinks that the active client has died and it will restart the process on the second client. We'll go back to our DB remote client to remotely access the database using the exact same virtual IP. So as far as this client is concerned, nothing has changed. It's still using the same hostname, which is DB client VIP, and we'll confirm that the entries that we had inserted before the failover still exist. So now we have verified when the database fails over from DB client 1 to DB client 2, it is still accessible and all the entries in the database are still valid. Now for second part of the demo, we'll clone our database and mount it on Azure client. Let's start by creating a snapshot of our Hedvig volume. You'll see that Hedvig snapshots are instant snapshots, and once these snapshots are created, they're ready to be cloned. So we'll create a clone of this snapshot, give it a new name, and we can also change the replication policy such that one of the replicas reside in Azure and the second one reside in one of our on-prem data centers, which is DC1 residing in West Coast. Rest of the steps are similar to our base disk, which is adding a LUN using the proxy in Azure Cloud. And the third step is providing access to our client, which is Azure Client. And now we can log in to this database using the same username and password that we had used in our base MySQL instance. Let's also verify the entries in this database. This verifies that both base and clone database are running in parallel